Hello, everyone. My name is Rich Martin, Senior Technical Marketing Engineer at Itential. And today I'm going to talk about, in this session, how to automate configuration standardization with Itential's platform, which is a natural lead-in on this journey that Peter started us off in. And so what we're going to take a look at today is we've got a script that was very little guardrails built into it. And our automation configuration part of our platform, configuration manager is what it's called, we're going to be able to address that and then start building these guardrails into this automation script. And so the reality of today's config management process is really chaotic. I think everybody can think through, they've been somewhere where this was the truth. We have a lot of network devices. Configuration backups really are happening on the most important devices on the network, mainly the core network devices. Lots of configuration backups happening kind of on a one-off basis. So they end up being like sprayed around on different people's laptops and desktops. When there's a need for those configurations, it's a scramble to find them. And then unfortunately, there is a lot of devices on the network that have never had a backup configuration, or if they did, it is so old to be basically useless. And so that is always a problem. However, in our configuration manager feature, not only do we solve that problem by onboarding a federated inventory from different sources. These can be network devices, traditional CLI based. They can be API, using API techniques for management. We onboard those into a federated inventory. And then from that, we can automate configuration backup. Now, that in itself is table stakes. Really where we want to head, especially for this demonstration, is that becomes the foundation that we use to build configuration standards. And this is an even bigger problem. Standardizing configuration for network devices, really talking about compliance. And so now within the same platform, we can not only solve the problem of just making sure we have the insurance policy of configuration backups across every device, CLI or API based, but then now we can start to create golden configuration templates that become the configuration standards that will implement in an automation to give us the guardrails we need to ensure that the network, proposed configuration commands that are going to be made to a device, making sure those are compliant, even before they're made to the device, they're applied to a device. That could be CLI or even API driven. And so that's where we're going to head to first in this part of the demonstration. So with that said, let's go into the demo. So like I said earlier, this is Configuration Manager. I talked a bit about the federated devices. They appear here on the left, and we've got a lot of devices in our demo lab here. Some of them are Cisco iOS. We have Juniper. We have Arista. We can take snapshot backups here. Everything can be automated. So every feature in Configuration Manager can be automated within our automation platform. Not only that, we have traditional CLI devices, but we also have API-driven network cloud services, in this case, AWS VPCs here. So we can pull those, we can even make backups of those configurations. And what that looks like is we can load the configuration in real time. Instead of your typical CLI interface, we're we're doing API calls into AWS and getting a description of the configuration for this particular VPC. And this, just like a CLI listing for a backup config, can become the standard that we start to build golden configurations with. And so when we do that, when we schedule that and automate these configuration backups that are in the federated inventory, now we not only solve the problem of making sure everything is consistent and easy to find, we have backups that are searchable, but now they become the groundwork for building golden configuration templates. And really, this becomes the guardrails that we're about to implement around that script that Peter onboarded. So in this demonstration, we have created our own little NFD data center. And let me give you some context here. So if you look, we have a global data centers section here. Think of this as a base. And every line of this configuration tree inherits from whatever is above it. So I can actually start to add configuration lines for routers at the global data center level, which will now be inherited into every other level here. So if I do something like this, and I can save it. Okay, now this has become a standard that devices will have to adhere to. And rightly, this is a bad idea, right? So obviously you would never want to do that. In fact, we want to do the opposite of this. We want to ensure that this never appears on any of our network devices, especially here in our core devices in the data center. So we have the ability to create some rules around it. Right now, that's a required rule. We can ignore it. Obviously, we want to disallow it. So when we disallow it, this should never appear in any of our configurations that are part of devices that are now being compared to this. So next, we'll create, we see Atlanta, San Francisco, Chicago. I will create a new node under that because this is supposed to be a global data center. So, whoops. Let's just rename this London. Now, if I look at the configuration of London, it's already inherited that global configuration under the configuration we just added for global data centers. So this allows you to take relevant, more universally or globally relevant configuration commands, put them at the higher level, and then create more locally relevant configuration standards in the trees under it. So with London, how do we get started? This is always a question that we get from our customers. How do I get started doing this? And the easiest thing, since we federated an inventory and have that available to us, is I can actually pull a live config from a router. What we usually say is, what is the device that seems to be the most, has the most standardization? Let's just import that config and start there. And then we can start to build configuration standards around that. So I pulled in the whole configuration. Obviously, we want to kind of pare this down a little bit. For this demo, we're going to instantiate a new interface and essentially loop back just because it's a demo and that's an easy thing to do. So I'm just going to pare that down. And that's coming from a live device in London. It has no configuration standards built around what a loopback interface should look like, what IP addresses are there. It's kind of all over the table. And so while this is a good starting point, we really want to start from here and build something that's more relevant to lots of different devices that can now exist under this configuration tree. So let me click over to Atlanta and look at this configuration. So now we've kind of simplified things. Now we've determined some standardization around loopback interfaces that are in Atlanta. So what this is saying is, and you'll notice we're using regular expression matching so that we can make this applicable to multiple devices. So if we align this to core devices in Atlanta, what this is saying is, if a loopback device gets created, it needs to be using something in the 300 range. This is always an annoying one for a network engineer when interfaces don't have descriptions or they have descriptions that don't mean anything. So in this case, we want to at least give a description where it's ATL identifying where it is, and then ideally some sort of service identifier after the word service to give it something that gives us information, and ultimately it helps us save time when we have an up-to-date and relevant description on a port and we're trying to troubleshoot or just look at something. And because we need to have a good subnet that's actually routed at Atlanta, why don't we build rules around the IP addresses that are actually assigned to these loopback addresses to make sure that they fit the standard. So with that, we've created 3 configuration standard lines that can now be applied to multiple devices. So under managed devices, I can go here and add the 4 core ATL devices that we have in our lab. And now all of a sudden, these 4 devices, when a compliance check or a validation check is done, we'll use this as the standard to compare their configurations to. And once we've done that, it makes it very easy now to even just copy and paste and create the same kinds of standards for San Francisco, which is now in loopback the loopback number of 200 with a slightly different description, with a different set of IP addresses, and then Chicago as well. And so now we can very quickly iterate and create these. And then this could be also an entire group just focused on this part of our application, saying, hey, we'll live in this platform building and ensuring that the compliance standards are built. But now we can start to leverage this because this becomes part of multiple levels of guardrails that we can use within automations in Automation Studio. So let me flip over to there and start off with where Peter left off. Peter left us off with onboarding a script. That shell script is here. It's a one-liner. We could run it. If we ran it, it has no guardrails. So it's relying upon the person running it to ensure that whatever we input as the inputs to the script are compliant, are correct, those kind of things. And of course, if we're trying to make this applicable across the entire enterprise to be run, we need to do better than that. And so I'm going to show you the demo for part 2 where we've added some things to that. So if I scroll down here, take a look at the shell script, that's where it started, okay? And now we're adding levels of guardrails and safety nets here because it's about building trust and confidence. If we don't trust and have confidence in our automations, regardless of their native within our platform or some sort of Ansible playbook or script, then we'll never really use them, right? They're too dangerous. So how do we now add to this script and build in some validation? So validation is I've got a couple of steps of validation here. Validation allows us to take a proposed configuration, ask the configuration manager compliance engine to say, if I were to add this configuration, the snippet of configuration in this case, creating an interface, loopback interface, to this particular router, we'll give it the host name of the router, the IP address of the router, and based off of the current standards that you've defined, that we've defined here for Atlanta, would that pass or fail that compliance check or that validation check? So that before that even gets started, we want to make sure that we do at least a single pass of the proposed configuration before it even gets to the script to ensure it passes muster with our compliance rules. If it does, then it's going to go down to a pre-check, which is another level of check that we're going to do, another guardrail. But if not, it's going to go down this path where we actually stop just for the purpose of this demo, we're going to stop the demo and take a look at what the validation error was. Along with that, we've added the ability to, within the automation, to pop up a form so that we can fill out that information that the script ultimately needs. But then that becomes part of the validation rules, right? We need to know the host name, the loopback interface, the description, those kind of things. So I can actually run it from here in the canvas, and I can start, and we can view the job running. And the first thing it's going to do is it's going to ask me to work at the task. So it's a manual thing where I can fill out the form that we created for this. So in this case, all 4 of my ATL devices are available. I can change the loopback interface. I can select these. Ideally, this, the way we've pre-filled the forms is compliant, but I want to show that we can make this not compliant, and so it doesn't pass the validation check. So I'm going to purposely do something wrong here. And then we can say it's going to validate the network change. That's the step that it's on. We can view this in a visualized way, so we can see this as it runs. So the validate network change completed. We have something called transformations. Transformations are a way to take the output of one task, manipulate that data so that it becomes the input for a next task. So it's just reformatting the data in a format that next task is. And if you think about APIs, you got to conform the data that you pass into the API to a certain spec. And that's what these transformations do, these JSTs. So in this case, it completed the validation decision, failed. So if we go back here, this is a manual task in blue. We've put that in here to stop this so that we can work the task and take a look at it. And the output that the validation check has said, this fails. The reason why it fails is because it does not adhere to the description for that interface. And because of that, it's going to take the failure path and not be implemented on the network. It's going to go around this side.
Back to that validation that you put in your manual, atl.service.star. We do anything more complex there, or is it just simple string matching, or can we do some fancy regex?
Oh yeah, that's just a simple regex. Yeah, you can use whatever regex pattern matching you want to use there. I'm just trying to keep it simple because too complex regex for myself and many others will blow our minds.
Oh, I understand that. I want to make sure because obviously we're not all ATL, right? So we.
Oh, of course.
Anyway. Okay, thanks.
Right. Yeah, no worries. All right, let me get back to my workflow here because we want to run it down the success path so that I can show you the second check that we've implemented here. So now we'll run it down the success path. And I take a look at it in visualization. This time it should pass through since we've kind of preloaded this to be compliant. It's going to pass through and get to a pre-check condition. The pre-check condition is actually using another feature in our platform called command templates. And this is awesome because while the validation check is looking at CLI syntax and then comparing it to the standard we built config manager, the command templates are actually, we can take a look at operational data. And the cool thing about this is network practitioners using the CLI, the CLI knowledge they already have. It's basically translating what they normally do as part of this process into a template that can run and do some pattern matching and come up with an output that we can parse on and determine if it passes or fails. So in this case, we're just doing a show CLI or show interface command on a router that we're building we're going to build that interface on. We're passing a variable called interface name. So in this case, loopback 301. And then the rules here, it should not contain loopback 301 is up. Loopbacks are always up when they're instantiated, but it should never contain that because that means it already exists and we might overwrite something, IP address, description, and that would be terrible. So that's the pre-check condition. If that pre-check condition is met, is found to be that it's not up, then therefore it will go ahead and create the interface with a script. And then after the script runs, we want to validate that operationally the interface actually was created. So we're doing the same command here, show interface loopback 301 will be the variable here. Now it must contain the interface is up, loopback 301 is up, which means it's up, it's instantiated, it's operationally up. But the second part of that is the output of that command needs to also include the IP address, because if the loopback's up, it needs to have the IP address, otherwise it's probably not going to work right. And so that's a very simple way now that another group of technical folks, networking folks, can get involved in creating another layer of guardrails for this particular script or any network automation, in fact, at the same time. And so this is the pre-check and the post-check. So a guardrail and a safety net as well. And so if I flip back over here to the workflow, refresh here. It actually went down the success path, completed the pre-check, completed the pre-check decision. It was a go, executed the script that was onboarded by Peter, ran the post-check and ended there. And so with that, to hopefully to help answer the question that Jordan earlier had is, once you onboard this, what is the value? The value is now somebody can work on the script to actually do things. They may not, the script writer may not even have the knowledge of what is compliant, what is not compliant. Another group altogether could be in Configuration Manager building the compliance piece, so for the validation check. And then other groups can be involved in the network automation in the sense of building these pre-check command templates. And that scratches the surface because we are a flexible automation platform. We can actually start to build all kinds of complex automations for pre-checks and post-checks. But hopefully this builds that next layer of the journey that says, onboard it now. Now using all these tools in our platform, now we can create these guardrails, safety nets that may not even exist in that script or that playbook.